hello folks. Well, another donation here to raise funds for the repeater Skiptech TS2000FM. So one of the also ran handhelds that work well. Mind you, I don't think I've seen 4 watts out of one, whatever BS they say. Made in Korea, specification. .8 volts will provide 4 watts maximum, and bizarrely 1 watt at low power. This is supposed to be 0.4 of a watt, and that was part of the specification, but there you go. Sensitivity better than 1 microvolt for 10 dB, so we'll see. So we can run it at 13.8 volts, and on battery it's going to be 12.5, and it's 10 AA's or 8 alkalines. Did I say that right? AA rechargeables, I meant there, 10. So you're ending up with 12 volts. Good. So no instruction book, but it does come with the inserts and the aerial and a lead to get us going on the test bench. I'll leave the aerial in the box. Notice it's BNC. Really handy and lossless. When I was at Nottingham Radio, we were doing business radio, but you know, if local people wanted CB help, we were always there to help. And I remember it was really having difficulty getting these. They were so popular. Bit of a bonkers thing, these 2 sockets are different, and you can end up with, see in this case this isn't quite the right plug, and this was made so the 2 different plugs were very slightly different. You couldn't fit the wrong one in. One's a thinner bore, but we're going to power it up, and that's been provided by the donor who's in the trade. Right, where is our power supply? It is here. He says it works, he's probably even serviced it, but we'll go through it anyway. He's also donated a Midland 77099. And something else that eludes me at the moment, and it's greatly appreciated. Got some scrap chassis too. See my light there, just in the what's it. Right, power on. We're going to power it up at 13.8 volts because it says so. We need the BNC adapter. Of course, I won't be able to find that, will I? Plug an extension speaker in, which is brilliant, so it's pretty versatile. They don't do external mics on these, so that's the only minus. Comes on channel 9 just to annoy everybody. Has a channel 9 switch. Let's put picture in picture on. And where did I put the sheet? If you think you're going to hear it into my walkie-talkie here on the bench, the walkie-talkie is as flat as a pancake. I came in here this morning and the walkie-talkie's been left on for 2 days. I'll go and find a pen. Right, having got myself a pen, Let's press transmit. So we're on the 3 watt scale. We're on low power, aren't we? Oh, we're on the high boom, boom, boom. 3 watts on the 3 watt scale and 0.95. 3 watts, 0.95 watts. Back to full power, and the current consumption is 808 milliamps. We'll do the other channels. I'll do a field test with this when we're done. Oh, that made me jump. Probably we've got the battery thing now for that 1/2 watt. Looks like a DNT duet that's come through. So it'd be nice to do a field test with both these. That has a telescopic aerial. This has the rubber duck. So 1/2 watt with a telescopic, 3 watts plus with probably about the same range. Probably get to scratchy corner anyway. We've probably done these before, but I do like these. I'm not bigging it up because we're selling it either. It's like 2.95 on that. Let's go to channel 1. 4 watts, 3 watts. Deviation for what it's worth on here. Let's pop it on that. Wallow. It's reading about 2 on there. And frequency. Test set's been on a reasonable time. Let's go to camera 2. And we've got 2779-107, 2779-107, that's fine. And no meters. Oh, good. I'll hold on that. Right, sensitivity. So we'll plug in our test equipment into the extension speaker socket. Check we don't need an earth. No, it's picking that up. Right, we'll go over to the cyanide meter. A bit more volume on so we get a fair. There we are for 12 dB and it's doing 0.8. .72. Sounds a bit slightly out on the detector, to be honest, but I may be wrong. 1.8. So it exceeds the specification that the manufacturer says it does. So that's a good start. Apart from on receive, I'm getting at, not on transmit. It's nice, strong squelch, just a little bit too strong. It's not, what is it, 560 microvolts threshold. Oh, that's not ideal. 2.2 microvolts. I mean, it does all sound a bit IF-y, that. Right, we'll open it up if we can remember how. We'll open it up if we can't remember how. worry about those screws. So you can unplug the speaker and mic, which is handy. Don't think we'll bother though. Yes, fiberglass printed circuit board on these, which at the time was unheard of. Crystal filtered receive. Now it's a copy of a copy of a copy, so it's not ideal. You can't really read the component values, but I'm just trying to see whether the power level is adjustable. So we've got our high and low power there, which is fixed. You can see we've got T2 in the receive. So that's going to be T1, 2, 3, 4. I can't read those. Still got to play it by ear. Let's pop it down to channel 20. It's guest time. Let's make sure we're on the main meter. I'd love to, if I could just find one reference part. But the trouble is they put the parts on top of the numbers. Can't see one part number for these coils. Anyway, the VCO is going to be in there. We're not going to touch that. Chances of that's going to be deviation. The only other thing it could therefore possibly have is squelch. Start there. Yeah, that's transmit. And that's now peaked. Try that one. That is also transmit. That's peaked. Now, is this going to be transmit, or are we on receive there? That's transmit, right. So that's peaked that. We're over 3 watts now. That looks like it ought to be transmit. And it is. These all look like, well, they look like dear, that's going to be transmit, surely. Right, well, we're a bit we're just over the 3 watts. I'm going to go on to receive. We'll just determine which is deviation. I'll use the tone generator for that. I'm not going to set it. I just want to determine which it is. So I'm expecting it to be there. It is. I'll take it back to where it was. So I'm right, that's deviation. So that's surely going to be squelch. I want to check that here and now as well. So I'm going to put the squelch on the radio. I'll see whether it alters when I twiddle this. It does. So that's squelch. So that's what I thought. I'm going to take this display board out without losing any knobs. So our thingy's there for the frequency, so I'll just do that with you. It's going to transmit. Just the crystal trimmer. I mean, it's neither here nor there, but it's just for the demonstration. That's a bit high. That's a bit low. That's a bit high. That'll do. 2779127. So we've got VCO there. That's going to be an early part of the receive. I don't know if we want to disturb that. We'll see. Put the cyanide meter up. Put a small signal on. See whether they have any effect. Doesn't like that tool. In fact, it doesn't like any of these tools. Wow, that doesn't seem right. I'll come back to that. That looks to be the detector. It's a bit more signal on. I'll put 100 microvolts. Let's go to the oscilloscope. The oscilloscope. That's it. No, it's not. Now we'll go down to 10 dB cyanide, 12 dB, sorry. Just turn the volume down a bit. Drop the attenuator a bit. Let's see whether that's transmit or receive. It's receive. Let's drop the signal. Yeah, definitely receive. You wouldn't have thought so. Well, that was out. Well, now we'll go back to a bigger signal. Not that big. Go back to a big signal and the oscilloscope. I think we're there. So we've now got 0.37 for 12 dB cyanide. For 10 dB, 0.32. For 20 dB, 1.2.3 dead. Now that can't be right. That can't be right. We've got something wrong. So which one of these is that one? I'm just going to look at these again. Not that one. Now look at that with a bigger signal on the oscilloscope. That's probably a good compromise. We've got 1.5 for 20 dB. Those are now going to be inferior. Zero 0.44. Zero 0.39. Let's look at squelch. Squelch to full. And we'll look at the attenuator. That's 100 microvolts. I want it to open at 100 microvolts if it will. Doesn't want to do that, does it? That's minimum. Let's see where we've... that's better. So we have improved that. It's now 250 microvolts for maximum. It was 560 before. Then, threshold, because that was lousy. It's just, you could say 0.95 microvolt. I'll put 1 microvolt. Because it's all tied in with the IF's tied in with the squelch. So, that is moving in the right direction. I'm going to do the deviation, and it's now like 9 o'clock in the evening. I'm going to call it a day with this, but we're about there. Not sure there's anything more we can do with the transmitter. But we have determined everything here is received. Transmitter is there. Right, we'll unplug from this test set. We'll go to the other one. Get the deviation done. It's going to be fun with the setting bits. I'm going to unplug the speaker so it's one less thing dangling. Wow, it's about 2.2 I think. Got the wrong glasses on, of course. Wow, let's prop that up a tiny fraction. Wallow. That, and I'll come back to it tomorrow. It might well be done, but you'll find out when we come back to it tomorrow whether I've put it together or whether we're just seeing if we can get another 100 milliwatts or whatever out of the transmitter. Okay, so we come back to this. I'm just going to take this shield plate off. I know there's no adjustments. I would really have liked it to do 3.5 watts, in line with most other hand portables which say they're 4 watts. It's like I've said before, my late father had a car which was a 1300 engine, 1.3 litre. Was it a Triumph Herald, something awful, and it rusted away after about 3 years. Anyway, point is, it was 1256. So it wasn't 1300 then, was it? No. And this is the same. They say 4 watts, and anything over 3.5 is of course 4 watts. And of course my watts are commercial test set watts and not hobby meter watts. And I've dropped this. What I'm just going to do is just pop this shield plate off. I've got another one of these which we've done previously, and we'll compare the two for transmitted power. So clearly you're not supposed to be doing anything in here, if there is anything. It's gone about 7:15, so I really need to bring this to an end so we can do a test. I'm not actually doing much levering with this precision tool. Because I think that there is kind of that final adjustment. Put picture in picture on and show the main meter. So full scale deflection is 3 watts. We'll key it up. We've got full scale deflection. I'm going to go to the other scale. So now 3 watts is here. Just see placement of these cores is critical. Definitely. Yep, 3.2. It's warm, of course, now, the set. I've just checked the previous stage. Now can't remember whether it was that one involved. Definitely is. 6.2. don't know what I'm doing wrong. It doesn't want to go together. No, nothing. Low power is now, it's supposed to be 1 watt. Let's go to lower scale. It's 900 milliamp. It's just same. It's actually 0.9. Right, I'll get some screws in this. And we'll pop it on the air. I just want to check the other one with you, which we previously did. This one's got its belt clip, and they look just like the Maxon Apex series of business radio belt clips, also from Korea. Right, let's get the aerial on this one. One on a Roger. And what we'll just do is pop the power off that one. I'll see whether this one, which we've done previously, exactly the same, 3 watts, and on low power 900 mil. They're absolutely identical. That's reassuring, isn't it? Yes, Mr. Tango. So there we have it, the Skiptech TS2000. I think they were from about 1990. I don't know whether there's a date code that gives either of these away. You got 9404. I mean, it could be 94. It could be. I hope so. I put that screw back. And what we'll do is we'll do a field test with its own rubber duck, and at the same time we'll do a field test with that duet. Now we've got the battery compartment parts come through. So thank you for watching. Skiptech TS2000, probably from early 90s.